Alright, so in this problem we're trying to determine the empirical formula of a substance that contains only carbon, hydrogen, and nitrogen. Our original sample is 35.0 milligrams, and that's purely carbon, nitrogen, and hydrogen. It tells you that after combustion you form 0.0335 grams of carbon dioxide, 0.0411 grams of water, and you don't know how much nitrogen oxide compound forms. But from these two pieces of information, if we know how much carbon we have and how much hydrogen we have, we could figure out how much nitrogen we have, and that would allow us to then get to the empirical formula. So first things first, when we're in grams, we go to moles. So if you know grams of carbon dioxide, this is 44 grams in a mole, you can figure out how many moles of carbon dioxide you have. Now, for carbon dioxide, you have one carbon atom for every one molecule of carbon dioxide. So the number of moles remains the same. That's how many moles of carbon you have, which would eventually give you 9.12 milligrams of carbon. You do the same thing for the water, except with water there's two hydrogen atoms for every one molecule of water. So you can then find the moles of hydrogen and therefore the milligrams of hydrogen. Now when you add those two up, you get 13.72 milligrams of carbon and hydrogen combined. So we go over here. If we subtract that mass from the original mass of the sample, we'd find that the sample contained 21.3 milligrams of nitrogen. So, again, when you're in grams, you must go to moles to relate amounts of a substance. 0.0213 grams of nitrogen, you divide by the molar mass, which is 14, you'd have 1.5 times 10 to the negative third moles of nitrogen. Now, from here, you can relate the amount of each by dividing by the lowest number, and that'll give you a ratio. So, the lowest number out of those three number of moles is 7.6 times 10 to the negative fourth. So, when we divide this by itself, you have 1 mole of carbon. The ratio of hydrogen to that would be 6 times as much, because when you divide by that number, you get 6, approximately, for hydrogen. And then when you divide this by that number, you would get approximately 2. So our ratio is 1 mole of carbon for every 6 moles of hydrogen to every 2 moles of nitrogen, which I didn't write for some reason, giving an empirical formula of CH6N2.